Okay, we're going to do a couple of algebra practice here on solving radicals. So a radical is these square root signs here. We have to solve for x. There's an equal sign. So we're trying to figure out what value for x, when you do all this mumbo jumbo here on the left, is equal to 3. Now when you do solve for x on a normal situation, if you see add, you subtract. If you see subtract, you add. If you see multiply, you divide. And that's pretty much the same thing you're going to do here, but when you see a square root sign, you got to do the opposite of a square root sign, and the opposite of a square root sign is to square it. Now when you do square it, you must, whatever you do to the left side of an equal sign, you must do it to the right side. Okay? And so what happens here is the square root and the 2 go away, and you're left with x minus 4 is equal to 3 times 3 is 9. And then, of course, if we see minus 4, we add 4. So x is equal to 13. And 13, of course, is the correct answer, because if I just do this on the post note here, here is the original one. X minus 4 is equal to 3. And so if I actually put 13 here, 13 minus 4, which is 9, and the square root of 9 is 3. And so that's the number that will work. All right. Notice this minus 4 is under the radical. You want to wait till the radical sign is gone, and then you do the add 4 to both sides. So don't add 4 and make this thing 7 right at the beginning. If you are underneath, like number 3 here, if you are underneath the radical, like this minus 5, eventually you're going to add 5, but not until the square root sign is eliminated. See this minus 8, which is not underneath the square root sign? First thing you want to do is actually add 8 to both sides. And then, once you have done that, excuse me, you would, negative 3 plus 8 is positive 5. Now, instead of adding 5, we need to get rid of the square root bar. By squaring both sides, you have 5a minus 5, because this bar and the 2 go away, is equal to 25. We're going to add 5 to both sides, that's 30. And so if I divide by 5, the answer there is 6. Okay? Plug in 6 here, multiply by 5, minus 5, square root of that. Add that with negative 8, you should get negative 3. But notice the slight difference of when you have numbers underneath the radical, they wait, and then when numbers are just on their own, you get rid of them early. Okay? I want to hit another number here. Okay, let's try number 7. Oh, by the way, with this negative 6 for number 4 here, this is negative 6 times the radical. It's not minus sign. It's a negative 6. So instead of adding 6, you're actually going to have to divide by negative 6 first. Negative and negative is positive 2. And then get rid of the square root sign and continue on with number 4 there. I actually wanted to hit number 7 here. And this is where we actually have x in 2 different spaces. We have an x underneath the radical sign and an x outside the radical sign. This one is going to be quite involved, this problem here. First thing we're going to do is to get rid of the square root sign. We're going to square both sides. Everything on the left, that's pretty easy. It's going to be 30 minus x, because the square root and the 2 just cancel each other out. On this side, though, we got x squared. That is a problem, because now it went from a radical type problem to a quadratic type problem. And if you recall quadratics, you're going to get usually 2 answers. We are going to get everything equal to 0. So why don't I do this? I'm going to minus this 30, and I'm going to add this x here. I'm going to add the x to the other side and minus 30 here. So this cancels out, cancels out. We've got 0 is equal to x squared plus x minus 30. Now there are a bunch of ways to solve this. You can use quadratic formula, negative b plus or minus the square root of b squared minus 4ac divided by 2a. Or you can do the zero product property, which is what I'm going to do now. I'm going to turn this into the multiplication of 2 numbers. I've got x and x gives me x squared. The back times the back multiplied to negative 30. So what 2 numbers multiply to negative 30? And they add up to 1 here. Well, this will be a 6 and a 5. And if it's a positive one, I want a positive 6 and a minus 5 there. So a plus 6 and a minus 5. Positive 6 minus 5 multiplied to negative 30, and yet they add up to negative 1 there. We're not quite done yet. We're going to say x plus 6 is equal to 0, and also x minus 5 is equal to 0. Whenever you have a quadratic, expect two answers. One of the answers is negative 6, and the other answer is 5. Now, those two answers will work when you plug them in here. This one here is called an extraneous result, meaning, normally when you take the square root of a number like 25, we only think of positive 5. But there is another answer. It can also equal negative 5, because negative 5 times negative 5 still is positive 25. And that's what this negative 6 is. It's an extraneous answer here. So if I put the negative 6 back into this original problem here, 30 minus x is equal to, underneath the radical is equal to x, and I put the negative 6 here and here, you would get 30 minus a negative 6 is equal to negative 6. This is an extraneous answer result. That's 36, by the way. Normally when we see the square root of 36, we think of positive 6. Well, this is when it turns into that negative result. By the way, we did mention there was another answer. The other answer is 5. And we can put the 5 here. 30 minus x is equal to x. Put a 5 there where the x is. 30 minus 5 is 25, and of course, this is the other answer. Okay? So you're going to square both sides. You're going to end up with a quadratic. Get it to 0. Get your two answers. That's going to be the case for number 8, 9, 10, and even 11 there. Okay, I'm going to do number 10 here. And this is just same process, but it's just going to be super duper hard algebra. Got the square root bar there. There's no point in minusing 3 because you can't minus the 3 underneath the 8, because really this is not a regular number 8 here. So don't minus 3 because that's not an 8. It's like the square root of 8, which is not 8. What we're going to do though is square both sides. And what makes this hard is this right side is going to be in parentheses. So we're going to cancel. The left side is easy. That's 4x plus 8. Now this, it's not going to be, and don't make this mistake. Don't go, well, x times x is x squared. 3 times 3 is 9. That is wrong. This is the box method. This is FOIL. It's x plus 3, x plus 3. You will get x plus 3 times itself. You will get x squared, 3x, 3x, and 3 times 3 is 9. You're going to end up with x squared. 3 plus 3 is 6x plus 9. I know it's real sloppy here, but I'm assuming this will come back into your memory bank. But you do have this middle term. It is not just multiply the front, multiply the back. You have a middle term there, 6x. Okay, x squared is a problem. We know this is a quadratic. It's going to be equal to 0. We want to make it equal to 0 first, so we're going to minus 4x over, minus the 8. We're going to expect two answers. That cancels that. There's 0. X squared, 6 minus 4 is positive 2. 9 minus 1 is positive 1. Okay, we are going to now factor this, split it into the multiplication of two numbers here. X and x. What two numbers multiply to 1 add up to 2? 1 times 1 is 1. 1 plus 1 is 2. So this is plus 1 plus 1. When you figure this out, even though it looks like we're about to get two answers, really you're only going to get one answer because that one answer is repeated twice. Negative 1 is the answer. Or you can say negative 1 twice, but it's the answer. Negative 1. And again, if I put negative 1 here and here, both sides will be equal.